Hello everyone, welcome to JGK Masterclass. Guys, in today's video we will learn about catenane and rotaxane. You might have heard about these two names if you are studying in M.sc chemistry. So these two are considered to be supramolecules, and here we will discuss this topic under stereochemistry, and we will see the definition, structure and optical activity based on these two topics and the problem related to it. The topic is important for M.sc students and those who are appearing for CSIR and GATE examination, and the examination like other competitive examination if you are going to appear. So we'll continue. So this is the first problem. Provide an example each for catenane and rotaxane. The problem is taken from the M.sc previous year question paper. So first we will see what is catenane. So catenane is a compound consisting of two or more rings that are interlocked mechanically without there being necessarily any chemical bond between the two. So as you can see, there are two or more rings which are interlocked but not chemically, it is mechanically. Mechanically means there is no chemical bond between the two rings. Okay, so first we will see in general example, there are two rings here and you can see both the rings are interlocked. First ring, as you can see here, it is having a macromolecule. Many atoms are there and that are connected through chemical bond. And similarly, the other ring also are having many atoms and that is also connected through the chemical bond. But there is no chemical bond between the two rings. It is mechanical bond. Okay, so mechanical bond actually doesn't exist here. So we are saying mechanical bond. There is no chemical bond here. And why we have written here two? Because there are two rings. So through the nomenclature, based on the number of rings, we will give here and write the number of rings as a in the square bracket. So two rings means two catenane here. You'll see the example. So as you can see, there are two rings. You can see in the first ring there is a chain of 20 carbons. In other ring also there is a chain of 20 carbons. And cat is also comes from the Latin word which means chain. Okay, so here two rings are there. So it is two catenane, and since it is cyclic, so we can say two cyclo icosane. Icosane means 20 number, and there is two cycloicosane because two rings are having the same number of carbon atoms, catenane. So this is a nomenclature of the following catenane. Rotaxanes are long, fairly linear molecules consisting of a dumbbell shaped molecules threaded through a macrocyclic ring. So as you can see from the definition, there is a macrocyclic ring and you have a linear molecular chain also here, and which looks like a dumbbelled molecule. So we will see the general example. As you can see, this bar looks like a dumbbell. Okay, at the end you can see the bulkiness here, and it has a ring also. So macrocyclic ring means many atoms will be there in this ring and you have an axis. Okay, so rota means also a wheel, which is from the Latin word, and axane means the axis. So you have an axis and you have a ring and you have the two bulky groups at the end of this linear chain. Okay, so this is considered to be rotaxane. So what is the difference between catenane and rotaxane? Catenane, you have rings. Okay, it may be two or more number of rings, while here you have one or maybe more rings, but along with that you have a linear molecule and on which at the end you have bulky groups. So you can easily distinguish. We'll see one example here also. You can see here there is a long axis, and at the termination of both the axes, the end of the axis, you can see a R, which is a bulky group. Here R is a aryl group, and you have a ring also which is consist of 20 carbon. So how we can name it, since it is having two, one is the ring, other is the axis. So two, and then 110 diaryl decane, because there is 10 carbon chain, and at the one position and 10th position you have aryl group. 110 diaryl decane for 10. Then you have cycloicosane rotaxane. So very easy to naming also. So if they ask you the definition and structure of or example of Catenane rotaxane, you can give this particular statement and example. Now we'll go to the next question, which is give an account of optical activity of two catenanes. Okay, so they're asking optical activity of two catenanes, how we can define that. So catenane bearing no substituents do not occur as optical isomers. So if there is no substitution on the ring, then it is achiral. Okay. Next, catenane in which each subunit contains two substituents, okay, located on the same ring, stereochemically, that we can relate to alene and spiral compounds. Okay, so if you might have watched about and learn about allenes and spiral compounds, so we can similarly tell about the stereochemistry of catenane, like allene you have done and spiral compounds you have done. Same way we can find the stereochemistry of catenanes. If each ring has two substituents, for example A and B, and necessary condition for it to have the enantiomers is the A should not be equal to B. So basically, if the two substitutions are present on each ring, and that is A and B, so the condition for having the optical isomerism is it should not be equal. A should not equal to B. You can see this is a two ring, and the two rings are perpendicular to each other. Okay, so that is another condition. And A should not be equal to B. Okay, the molecule should be, we will see this term in the next point, dissymmetrically substituted. So we'll see what is that. If each ring of catenane has same two substituent R on different ring, then in that case it is chiral, right? It means if the both the substituent are similar, and even though if the rings are dissymmetrically substituted. Dissymmetrically means the molecule does not possesses any plane or point of symmetry. It will possess only the axis of symmetry. So it is having the axis of symmetry because the two rings are perpendicular to each other, and even though it is achiral, you can see, because both the substituents are similar, R here. So basically the condition for catenane or to have a stereochemistry or to possess a stereochemistry or to have the optical isomerism, that both R should be unequal and the two rings should be dissymmetrically substituted perpendicular to each other. So I hope you understood about the optical activity of 2-catenane. Okay, why we are saying 2? Because 2 rings are there. You may have here more number of rings. Okay, so since we were discussing about the questions which are M.sc previous year, we discussed about these two topics. So if you want me to prepare and if you want to know about more details on catenane and rotaxanes, you do write it in the comment section. I will try to prepare that. Moreover, if you want me to prepare allenes or spiro compounds or any other molecule for which you want me to write or give you details about the stereochemistry or any other topic you want me to prepare, you do write it in the comment section. So I hope you understand this catenane and rotaxanes, and you can use this detail for your exam. And I request you all, if you are liking my videos, please do share it with your friends and subscribe my channel. Please do like it. It will motivate me to prepare more and more videos. Thank you.